Good day everyone. Today we'll discuss differential calculus, differentiation of trigonometric and inverse trigonometric functions, sample problems and step-by-step solution. Our module objective for this topic: after the completion of this module, students should be able to number 1, analyze and solve problems related to the differentiation of trigonometric functions, and analyze and solve problems related to the differentiation of inverse trigonometric functions. The last time, in our part 2 lecture, differentiation of trigonometric functions, we discussed different formula like this one. Formula number 1, d over dx sin u is equals to cosine u du dx. Second formula, d over dx cosine u is equals to negative sin u du dx. Third formula, d over dx tangent u is equals to secant squared u du over dx. For the fourth formula, d over dx cotangent u equals to negative cosecant squared u du over dx. Number 5 is d over dx secant u equals to secant u tangent u du over dx. And for the last formula, d over dx cosecant u is equals to negative cosecant u cotangent u du dx. Let's proceed now to our sample problems in differentiation of trigonometric functions. Problem number 1, y equals to sine 5x. So here, the given is in sine form, so we'll use our formula number 1, which is equals to d over dx sine u is equals to cosine u du over dx. Then, dy over dx is equals to d over dx sine 5x. Then, by using the formula number 1, it would now be cosine 5x here. The sine 5x will be converted into cosine u. So, cosine 5x. Then, our u here is 5x. So, du over dx equals to d over dx 5x. Then, we will have to differentiate the 5x. So, our answer now is 5 cosine x. And the differentiation of d over dx 5x is equals to 5 here. So our final answer is 5 cosine 5x. So let's proceed to our sample number 2. X is equals to tangent u. So our problem is in tangent form, so we'll use our formula number 3, d over dx tangent u is equals to secant squared u du dx. So our u here is 2u. Then dx over du is equals to d over du tangent u is equals to secant squared 2u. So this is formula comes from this one, secant squared u. Then our u here is 2u, so d over du 2u. Then our final answer is the differentiation of this one, d over du 2u is equals to 2. Then we have to copy this form, secant squared 2u. So this is now our final answer. For sample number 3, r equals to secant 6 theta. Our problem here is in secant form, so we'll use formula number 5. d over dx secant u is equals to secant u tangent u du over dx. Then, dr over theta is equals to d theta secant 6 theta. Then we'll have to substitute our form here. Our u is 6 theta, so secant here. Then our u is 6 theta, tangent. Then u again, which is the 6 theta. Then d over dx, so equivalent here is d over d theta times our u, which is 6 theta. Then we'll have to differentiate this one. So 6 theta d over d theta is 6, and we'll just have to copy this form. Secant 6 theta tangent 6 theta. So our answer for example number 3 is this one. So for problem number 4, y equals to secant squared x minus tangent squared x. So here we have two different forms, the secant form and the tangent form. So we will use formula number 5 for the secant form and formula number 3 for the tangent form. Then dy over dx is equals to d over dx secant squared x tangent x squared. So now we will divide this form into 2 so that we can differentiate each individually. So here it is, d over dx secant squared x minus d over dx tangent squared x. Then, so for d over dx secant squared x, this is also in power form. So we have here the 2 secant x, then this formula sec u tangent u, so sec x tangent x minus, so for the second derivation here in tangent, we have 2 tangent x, okay, then the secant form here, secant squared x, okay, then we have to combine 2 secant squared x tangent x minus 2 secant squared x tangent x. So 2 secant squared x tangent x minus 2 secant squared x tangent x, this is equals to 0. So the answer for our problem number 4 is 0. So for example number 5, r is equals to cosine theta cotangent theta. So here we will also use two forms. For cosine u, we will use formula number 2, and for cotangent u, we'll use the formula number 4. So we'll have to combine the two forms. Then dr over theta is equals to d over d theta cosine theta and cotangent theta. Next, so we have now to divide this into two forms. So for cosine theta, this is it, cosine theta over d theta times cotangent u plus cotangent u d over d theta cosine u. Okay, multiplication. Our next topic is differentiation of inverse trigonometric functions. The following formulas are used for differentiating inverse trigonometric functions. The symbol u denotes an arbitrary differentiable function of x. Number 1, d over dx arc sin u equals to 1 over square root of 1 minus u squared times du over dx. Second formula, d over dx arc cosine u is equals to negative 1 over square root of 1 minus u squared times du over dx. Formula number 3, d over dx arc tangent u is equals to 1 over 1 plus u squared times du over dx. Formula number 4 is d over dx arc cotangent u is equals to negative 1 over 1 plus u squared du over dx. Formula number 5, d over dx arc secant u is equals to 1 over u over times square root of u squared minus 1 times du over dx, and last is d over dx arc cosecant u is equals to negative 1 over u times square root of u squared minus 1 times du over dx. Let's go now to the sample problems for the differentiation of inverse trigonometric functions. For sample number 1, given equals to arc sine 3/5, find all the functions of y. So here we have to draw the triangle. So we have arc sine. Y equals to arc sine 3/5 here. So our hypotenuse is 5. Our adjacent here is 4 and the opposite is 3. Solution, arc sine 3/5. So therefore, sine y equals to 3/5. Thus, cosine y is equals to, here is adjacent over hypotenuse, which is equivalent to 4/5. Then tangent y is opposite over adjacent. Tangent y equals to 3/4. And for cotangent y is equals to 4/3. So adjacent over opposite. Secant y is 5/4. So hypotenuse over adjacent. And for cosecant y is equals to hypotenuse over opposite sides, which is equivalent to 5/3. Sample number 2, cosine arc sine x is equals to square root of 1 minus x squared. The figure shows the triangle with the opposite side x, hypotenuse 1, adjacent is square root of 1 minus x squared, then with the angle theta. So let theta is equals to arc sine x. Therefore, sine theta is equals to x/1, or in short, simple, sine theta is equals to x. So from the figure, cosine theta is equals to adjacent over hypotenuse, which is equivalent to square root of 1 minus x squared over 1. Thus, cosine arc sine theta is equals to square root of 1 minus x squared. Sample number 3, y equals to arc sine 3x. So here our problem is in arc sine form, so we'll use formula number 1. d over dx arc sine u is equals to 1 over square root of 1 u squared du over dx. So our u here is 3x. Then d over dx times the u here is 3x over 1 minus u squared. So our u again is 3x, so 3x squared. Therefore, our answer is the differentiation of this one. D over dx times 3x is equals to 3. We just need to simplify this form. Square root of 1 minus 3x squared is equivalent to 1 minus 9x squared. So our final answer is 3 over square root of 1 minus 9x squared. So for problem number 4, x is equals to arc cosine square root 1 minus 2t. So the problem here is in arc cosine form, so we'll use the arc cosine formula. D over dx arc cosine u is equals to negative 1 over square root of 1 minus u squared du over ux, where our u is equivalent to square root of 1 minus 2t. So here we can use another formula from previous topic, which we call power rule. So from our power rule formula, we have n times u times n minus 1 du over dx. So our n here is, can convert the square root of 1 minus 2t into open parenthesis 1 minus 2t raised to 1/2. So our n here is 1/2. Okay, then our u is 2t. So we can rewrite this in this form. So d over dt square root of 1 minus 2t over square root of 1 minus our u here is this one. So square root of 1 minus 2t squared is equivalent to 1 minus 2t. Then we will apply this power rule from here. So negative 1/2 t, this one. So our n is 1/2. So negative 1/2, because this is a negative here, that's why it becomes negative here, times 1 minus 2t. Then 1/2 minus 1, so our n here is 1/2. That's why we have 1/2 here. Then times the d over dx of 2t here, which is equivalent to 2, negative 2, over 1 minus 1 is 0, minus 2t, so what's left here is square root of 2t. Therefore, this equals to 1 over 2t, square root of 2t times 1 minus 2t. So we can still simplify this one into 2t minus 4t squared. Sample number 5. Y is equals to square root arctan 2x. So our problem is in arctan form. So we'll use formula number 3. D over dx arctan mu is equals to 1 over 1 plus u squared du over dx, where our u is 2x. So here again we can rewrite this given into y equals to arctan 2x raised to 1/2. So as we can observe, we will still use here the power rule. Then dy over dx is equals to, by using power rule, so 1/2 now, where is our n, so we'll place here 1/2. Then arctan 2x, then 1 minus 1/2 here our n, so it becomes negative 1/2 times d over dx, so 2 over 1 plus our u here is 2x, so u squared is 4x squared, and then our final answer is 1 over 1 plus 4x here square root of arctan 2x, so the 2 here will cancel. So that's why our final answer is 1 over 1 plus 4x squared square root of arctan 2x. So for problem number 6, we have u is equals to arc cosecant 3/2. So our problem here is in arc cosecant form, so we'll use formula number 6. D over dx arc cosecant u is equals to negative 1 over u times square root of u squared minus 1 times du over dx. Then du over dt, because it's in u and in t form, equals to, again, power rule, 3 halves. Our cosecant, so our n is 3 halves. So minus 1 equal to 1 half times d over dt. Then our u is our cosecant. Yeah. The next, so our cosecant will use this conversion. So 3 halves our cosecant t, then negative 1 here over u. So our u here is t times square root of u squared, so t squared minus 1. Then our final answer now is equivalent to negative 1 times 3 is negative 3. Our cosecant t over here 2 times t, so 2t times square root of t squared minus 1. So this is our final answer for problem number 6. Sample problem number 3. A ladder 25 feet long leans against a vertical wall. If the lower end is pulled away at the rate of 6 feet per second, how fast is the angle between the ladder and the floor, changing when the lower end is 7 feet from the wall? Solution. In the figure, we let x is equals to distance of the lower end of the ladder AB from the wall CB. Then let the theta equals to angle between the ladder and the floor CA here. So we want to find here the d theta over dt when dx over dt is equals to 6 feet per second and x is equals to 7. So since cosine theta is equals to x over 25, then theta is equals to arc cosine x over 25. So differentiating with respect to time, so d over dx arc cosine u equals to negative 1 over square root of 1 minus u squared du over dx. So we use the formula for arc cosine form. Then d theta over dt is equals to negative 1 minus x squared over 625. So this is our u. So this one comes from x over 25 squared. So this equals to x squared over 25 squared, which is 625 times 1 over 25 t over dt. So this is in terms of time. Then substituting x equals to 7 and dx over dt is equals to 6. d theta over d time is equals to negative 1/4 radians per second. The minus signs indicates that theta is decreasing. This ends our presentation for part 3, differentiation of trigonometric and inverse trigonometric functions, sample problems with step-by-step solution. Thank you. Our next topic for part 4 is the differentiation of logarithmic and exponential functions will be uploaded separately.